Okay, picking up where we left off, we talked about the M.2 standard. It's a mechanical standard, for this next generation thing that plugs directly into a PCI Express slot. Most motherboards have like one slot. If you have a really super duper motherboard, you might have two, but that's about it. I mean, I don't know of any motherboards that have like 15 or 16, right? That don't happen. So in the corporate world, they use something slightly different. There's a tweak to a standard SATA drive. They have a smarter drive that's a little bit better. It's called SAS, and it stands for Serial Attached SCSI, which is another acronym which stands for Small Computer Systems Interface. It basically uses the same cabling, so you really can't look at the cabling and say, this is a SATA drive or this is a SAS drive, because the cables look remarkably similar. But there's a controller on the drive which handles queues, like asking for 5 things. It can do out of sequence things, like if you had in a server environment, you have 5 people asking for 5 different things, but this one and this one are asking for the same file, and this one asking for the same file, but they all hit in the wrong order. It can reorder the thing, saying, wait a minute, if I do this in a slightly different order, I can speed up performance. Obviously, they're more expensive. On USB on page 732, you guys know what all this stuff is about. So this is just a summary of all of the interfaces we talked about. It's confusing because the signaling rate really doesn't mean anything. The theoretical maximum normally doesn't mean anything. And here's the actual expected, what you can really expect. Now, there's an awful lot involved in this. I mean, the controller and the cabling and like for spinners, it doesn't matter what the interface speed is, because the actual transfer rate of the device is not going to get any faster. We don't need a SATA 4 because the SATA drives can't go faster than that. Unlike, the NVMe drives, man, you can get some stuff. There are some NVMe drives out there now, the new ones, that can do dang near, 12 gigabyte per second transfer rate. I mean, really, really, really close to the theoretical maximum. And then let's keep going. Attachment and low-level management on page 733. So SAS and USB are designed to be hot pluggable. That means you could take a drive and without turning it off, you could just unplug it. I mean, you've done this with a thumb drive, right? A USB flash drive before, where you just unplug it. I mean, you might get a warning saying, hey, you shouldn't do that, but it's not going to damage, it's not going to hurt much. So my motherboard has a way that I can go to the BIOS and tell it that my traditional SATA drive is also hot pluggable. That's what my my motherboard allows me to do. So I actually have a way of putting a drive into my machine and then pulling the drive out. Kind of cool. If you want to look at existing block devices, there's an LSBLK. I kind of mentioned it's kind of a different way of getting to, like we talked before. So remember how we use the block device, the hardware guy, to get the block devices? Okay, so I'm going to do LSBLK. And so it just lists all the block devices that it sees, okay? And it's basically the same thing as the LSHW guy, except you have to basically tell what you were looking for. This one's specifically designed for doing those guys. Okay, this basically tells me what is a disk and what is a partition, which is kind of cool, right? And tells me what's been loaded on there. For example, my SDB1 has the /public installed on it because we did that during one of the classes. So formatting and spare blocks. Remember when we ran the MKFS? It came back with a report telling us that I've set aside some spare spots on the drive in case they go bad. Yeah, it's called spare blocks. And so if something goes wrong, I can do something. Secure erase. In the old days, when it came time for you to dispose of your computer, remember I told you when you delete files off the thing, all it basically does is just take away the directory entry. It doesn't actually go to the hard drive and do anything. So I think, well, I know what I'll do. I'll just reformat my hard drive and that'll erase it all. So let's say you're in a Windows environment. So I'm getting ready to donate my computer to Goodwill or something, and I want to make sure I don't have any of my account stuff on there. And so I'll just do a format. I'll pop in a floppy disk and boot the thing up and do a format on the drive, and that'll erase it all. No, that is not erasing the drive. So there's a new thing called Secure Erase. And so Secure Erase is all about how to go in there and specifically make sure that it actually goes in and wipes out all the data. So we can do one called HD Parm, which is a utility that can go in and zero out an entire disk. Obviously, I'm not going to do that. Okay, we talked about Smart, where it keeps track of scan errors and relocation counts and blah, 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 blah. In a normal world, you'd install something called Smart Mon Tools, all one word, Smart Mon Tools. But since we have a fake system, there's no real need for us to do this, because I don't think VirtualBox supports the Smart API on its virtual disks, because that just wouldn't make any sense, right? So yeah, it's in there. Yes, it's in the book, but don't try it at home because it won't make any sense. Okay, on page 739, they start talking about the elements of a storage. So we've done an awful lot of this, so let's just go through it. So I have some sort of a device, and then I have a partition, and then I have what's called a volume group, which means I could have multiple disks appear as a single volume. Okay, that sounds a little weird, but it's sort of like a poor man's RAID. I could take two disks and bolt them together, two partitions, and bolt them together and make it look like one giant partition using a thing called volumes. And then you could have a RAID array. And then you could have the file systems on top. So the device, the physical device, could just have a partition going directly. It could go to a RAID, or it could go to a volume group. And it kind of sort of depends on how you got this thing. So there's an awful lot of commands associated with this, but we're not going to go into too much detail. Hard drive partitioning. Yeah, we did this on page 742. You have a kind of a choice when you're installing. One way to do it is just install everything on one giant partition. Don't be worried about it. Just do it, okay? That's one way of doing it. But to tell you the truth, that's probably not the way to do it. If you were to, for example, put, you have like two physical hard drives on here, and so this one has a partition 1, this has partition 2. Here's where I put home, here's where I put optional, here's where spare is, and maybe, I'm guessing there's another one somewhere where the boot drive is, right? Where the actual root is, but it doesn't show in this diagram. So, why would I want to partition this out? Why do I have to have a separate one for home and optional? Why do I do that? What would be the reason? Well, let's kind of go through the thing. So those are the guides. One is, have a backup of the root partition. We don't need that necessarily in our environment, but you could have like an extra partition out there just for your boot partition so you could back it up. Put temp in a separate file system, a separate disk all by itself, because it handles things differently than the rest of the disk system, because it's not designed to be persistent. So it doesn't have an awful lot of checkity stuff, because it knows its lifetime is small. Put the var log stuff in a separate partition so that if it overflows, it won't crash the rest of your system. Yeah, the log might overflow, but it's not going to take out all the stuff at the room in the home directory. If you have a home directory separate and apart in a separate hard drive partition, then you have lots of advantages. You can do backups of only people's files, or you can set disk quotas, right? How easy is it to back up just that one file system, that SD A1 guy that just contains the home directories? You might have a backup scheme that's slightly different for people's personal files, okay? And then swap, of course, that's typically a completely different file format, because it's not even formatted with anything like ext that we've seen before. So on page 744, they talk about the traditional partitioning tools. So there's one called the master boot record, which typically is the older stuff. It can't support disks that are bigger than 2 terabyte. It exists only in the 512 sector world, okay? And it only has 4 spots on the partition table. Okay, now I admit one of those spots could be an extended partition, but bear with me. So those are the old ones. The new one is called a GUID partition table. GUID is yet another acronym, globally a unique identifier, GUID. A GUID partition table. And so it uses 16-bit code for its title, its name, whatever. And it doesn't try to fit things into 512. It can go use that native 4K guy. And so you can have as many partitions as you want. Its partition table doesn't have to fit into a sector like the MBR guy did. That's why it was constrained. That's why you could only have 4 partitions, because I didn't physically have enough room in the 512 bytes to have an awful lot of other partitions going on. Logical volume management, page 747. So remember we talked about the volume manager where you can have multiple disks act as one. And there's some advantages. I can move data from one physical drive to another without anyone even noticing. I can grow and shrink a volume as my needs change. Kind of cool. On the fly, no less, with no data loss. I can take snapshots of volumes to compare later on. Lots of cool stuff. I can hot swap drives. I can do mirror and striping, all sorts of stuff. And so there's an awful lot of commands. We're not going to go through it, but there's an awful lot of commands about how you talk to a physical volume with PV, how you talk to a volume group with VGs, and how you talk to a logical volume with LVs. And again, we're not going to do that. I'm just saying there's an awful lot of these commands in there. On page 753, they talk about RAID finally. The original definition of RAID was a redundant array of inexpensive disks. That was the original name. And then they went, no, that makes it sound cheap. So they changed it to a redundant array of independent disks. So this used to be a big deal on whether or not I did my RAID in hardware or in software. Okay, they used to be a big deal because CPUs were kind of slow. But now, who cares? It doesn't matter, right? I mean, CPUs are fast enough, so I don't need to have a separate CPU on my disk controller handling RAID anymore. So hardware RAID is essentially gone. No one does hardware RAID hardly ever. Okay, there are different levels of RAID. There's one level of RAID that is called just a bunch of disks. That's what it's called. JBOD, just a bunch of disks, which means, hey, just throw a bunch of disks together and the heck with it. All we do is we throw a disk in and they all just act as one giant disk. Okay, RAID 0. RAID 0 is designed to speed things up. I have 2 disks, and so when I type Mary Had a Little Lamb, Mary Had a goes on this one, and Little Lamb goes on this one. So it actually speeds things up by splitting my request, and half of it gets stored over here, and half of it gets stored over there. So it's super fast. The problem with a RAID 0 is if one of the drives failed, I've lost everything. So a single failure means I've lost everything. That's not good. Okay. A RAID 1, it has the exact opposite goal in life. It is not about speed. It is about protection. So here what happens is I have 2 disks. I say, I want to store Mary Had a Little Lamb. It stores Mary Had a Little Lamb over here, and then Mary Had a Little Lamb on this one. The exact same information gets written to both drives. And the idea behind that is it doesn't speed it up at all. But if one of the drives failed, quite frankly, you probably wouldn't even notice. I mean, it'll give you a warning saying, warning, warning, my drive has failed, but you'd still be able to continue. So the goal for RAID 0 is speed, but at a horrible expense at reliability. The goal for RAID 1 is reliability, but I'm not getting any speed. And then a third option, there's actually quite a few more options than that. But a third option is called RAID 5. And RAID 5 is kind of sort of like the goal of RAID 1. But let's say I had 10 drives, okay? And and they're 2 terabytes apiece. 10 drives at 2 terabytes apiece. And I want to do a RAID 1? That means I only get 5, half of them get written to 5 and the same message gets written to the other 5? That's a heck of a lot of wasted space, isn't it, right? All right, hang on to that thought. We're coming up on the 15-minute mark.